Hello and welcome to today's session. My name is Paul Nashawaty and I'm in the Fermyon technology booth. I'm joined by Matt. Matt, welcome.
Yeah, thanks. Thanks for having me.
Yeah, it's great. It's really exciting times in the space. I mean, look at all the activity around us, in cloud native space. But let's talk about WASM. So what's Fermyon do?
So Fermyon is building the next wave of cloud computing, and we've focused on WebAssembly as that technology that enables a class of cloud computing we just haven't been able to crack up until this point. We like to talk about cloud computing as having waves, right? The first wave of cloud computing was the virtual machine-based wave, and it was when a little bookstore named Amazon suddenly became, a big technology company. They brought this idea that you could lease their hardware and run your virtual machines on there, and that was really the first wave. Then the second wave came along with the container ecosystem, where instead of packaging up sort of these big, gigantic images of an operating system and shipping it across the wire and running it and dealing with the minutes-long cold start time, you just package up sort of like a little pie-shaped slice of your operating system that's got just those core files that your server needs, just that part of the file system you need, and then you can package that in a container, ship it somewhere, and run it in an environment like Kubernetes. It turns out to be an excellent environment for running long-running processes. But what we started to see was this real interest in short-lived processes in sort of like that event-based programming model, where a request would come in, your software would launch, handle that request, return a response, and shut back down. And so when you're scaling and 10 requests come in, you're starting up 10 instances of this, processing as fast as possible and shutting them back down again. And in order to be able to run workloads at any scale using that particular model, you're gonna need some kind of runtime that can cold start very fast, that has very small binaries that can very quickly load into memory and execute. We couldn't achieve that level of compute with virtual machines. We couldn't do it with containers. And so we started looking around for a technology that had all the attributes you would need to run that kind of environment. WebAssembly very quickly bubbled up on our radar, and that's why we're so excited about it and have built all of our tooling on top of this really cool nascent technology.
It really is an exciting time. And when we talk about the business challenges, we see that application modernization is growing, but this is more than just an academic exercise. Let's talk about how WebAssembly is really crossing the chasm into like real life use cases.
So this morning on the keynote stage, we saw Michel Donani from Fermyon join Kai Walter from ZEISS and Ralph Squillace from Microsoft and talk about this really cool case that ZEISS has where they get a huge influx of orders, batches of 10,000, and they need to send them through this pipeline of data transformations before sending them off to the production facility. And being able to process those loads can be very expensive in Kubernetes because you have to provision for this max capacity. And what you really want to do instead is have a system that can scale up very rapidly, reach very high density, right? A lot of things running in only a modest amount of hardware, and then scale back down as near it to instantly as you can. And it was exciting to see that presentation on the stage today because that's one of those cases that we're hearing as people come and say, in manufacturing, we've got these near edge, far edge configurations where we have limited hardware capacity. We need to squeeze every last bit out of them. How do we do that? Well, density and WebAssembly is a really good way to go. Talked to a large publisher today, they're saying, you never know when you publish an article when it's going to go viral. Being able to scale up and then scale back down again as close to instantly as possible is critical for them to be able to do their job, right? Is critical to be able to meet the demands of the market. But they don't want to swallow the cost of having all this Kubernetes stuff running at idle, right? And the typical container implementations take so long to start up that you have to sort of scale up before the load comes in. And when you can't predict the load is going to come in, you end up staying scaled up much more often than you want. And so it was really exciting to see them come and say, this is the perfect use case for these kinds of cases where if something goes viral, scale up instantly, scale back down as soon as it's done, and you don't have a large sunk cost of keeping those compute instances running all the time.
Yeah, so far from academic, right? It's far from academic. There's clearly a great use case here. Performance, that's really one of the things that we're seeing, right? When we look at this application modernization approach, and we look at that burst capacity, that boost and moving up, you can over provision and it's very costly, right? And so you don't want to do that with the traditional models, right? So when I talk about the story of past, present, and future, I often talk about WASM as maybe being a future set of technology that's really helping with that growth of those applications. What are your thoughts on performance?
Yeah, I think the big word we tend to use is efficiency because it very much captures performance, scalability and cost control, right? And performance has been a critical piece of WebAssembly for us. When we built the Spin runtime, the kind of core of all of our offerings, Spin has to be able to cold start applications nearly instantly. So you look at a virtual machine, it takes minutes to start up. Container, dozen seconds, 2 dozen seconds. Even an Amazon Lambda function takes about 200 to 500 milliseconds. Spin takes 1/2 of a millisecond. So we're talking orders of magnitude beneath what, faster than what we've had before. And that's what enables you to be able to scale up really rapidly and scale down. It's what enables that density story, because when you can move things around faster, you can free up resources faster and consequently get more value out of it. And of course, the cost story falls right out of that, right? Because if you need less hardware and you can run things more densely and more efficiently, your cost of cloud is going to go down.
So it's not just cost, but it's also performance. And you mentioned ZEISS, right? Yeah. So let's talk about, on a recent briefing, we talked about SpinCube and how SpinCube can help with ZEISS. How did that kind of play into it?
And that was so SpinCube is our WebAssembly in Kubernetes offering. And Kubernetes has become one of the most popular, probably the most popular way to orchestrate container-based workloads. And it's proven to be a really effective platform for what is effectively distributed computing, right? Where I can push my workload out and have it scheduled across my entire cluster. But again, being based on containers, it's had that kind of slow startup time issue there, and consequently, Kubernetes is kind of known for having this over-provisioning problem. That's where, when ZEISS saw this, they said, oh, this is really interesting to us because we can pack a lot more of these WebAssembly serverless functions into very modest hardware than we would ever be able to achieve with containers. And consequently, we're handling that, like they showed today, those 10,000 queued requests much faster, or at least as fast as anything they'd have before, but at just a minuscule amount of the compute capacity they had needed before. SpinCube is really that technology that enables that. So provides you the way to install this into your Kubernetes cluster, manage these kind of applications. And the best part about it is that it all just feels like regular Kubernetes, right? You can run WebAssembly containers side by side, or WebAssembly serverless functions side by side with Docker containers. It all just works. And I think that's a powerful way to enter into a marketplace that already has established a lot of patterns, a lot of security best practices, a lot of development tooling, and we just fit right into that particular environment with something like SpinCube.
Well, I wrote down during our briefing, I was talking about how SpinCube and the deployment from a performance perspective is really multi-dimensional, right? It really kind of shows in that cold starts. I wrote down 200 nanoseconds and throughput being 60% better, and density being 50 times better than and we see it in the booth here. We see the messaging. It's amazing. I mean, it's amazing how fast and let's talk a little about those claims and why those claims matter.
And again, the reason they matter is because those are ways to really measure what you're talking about when you say efficiency. If you can run 50 times the number of apps per node in your Kubernetes cluster, 50 times, I mean, you can see right there that gone are the days where we have to run these 1,000 node clusters with huge allocations of memory and a huge number of cores, because we can really start fitting the applications in a nice tightly packed configuration. And that, again, that sub-millisecond startup time means that we can just churn through the requests as fast as they come in and not have to worry about this latency where the request comes in, there's a stall, and then something starts up and it returns it, and then this thing hangs around for a little while. Every little bit of time you can shave off of those is CPU that gets reallocated for something else. I think as we see compute really come into the limelight again now, with both GPU compute for AI workloads and traditional CPU compute, because we're all trying to control the cost of cloud, it makes a lot of sense when we can say, okay, you're hitting a density of 50 times, right? That means you can take modest hardware and accomplish huge workloads coming through there. Or as you get into the very GPU intensive world of AI development, you can do a lot more with those really costly GPUs as opposed to the kind of traditional model of lock a GPU for a long period of time, like days, months, weeks. You're locking them for a second here, 2 seconds there, a couple milliseconds there, and then you're releasing them, and consequently, once more, that density story bubbles right away up to the top.
Yeah, absolutely. When we look at this, the approach that we see a lot of times is a truly serverless approach. And so when we look at WASM, how is that, like, how do we educate the market on what that means?
Right, and that's a fantastic point, because the term serverless has gotten a little oversaturated as it got applied to some things that maybe weren't actually serverless. It became an unclear term. So we wanted to really carefully talk about, what do we mean when we say serverless? What is the server that we're doing without, right? And to us, the best way to articulate it was just in the plain old terms of how people do software development. So typically, a microservice, for example, when you write the code, you write a long-running server process that has a sophisticated set of handler functions in it, and it stays running for hours, days, months, maybe even years in some cases. And it's just running and accepting requests, sending out a response over and over again. As a developer, that means I have to code all of that and maintain all of that code around starting and running and maintaining this code. Every time there's a new OpenSSL version, I'm patching my code, I'm shipping everything out. Serverless is really that practice of saying, okay, we don't need that server part in the code. Something else can handle delegating requests. All I am writing, my only code artifact, is an event handler that takes a request, does its processing, returns a response, and shuts down. So we're going from hundreds or thousands of lines of code to potentially just a couple of dozen lines of code, which means easier to maintain. Smaller teams can maintain them. Easier to find vulnerabilities, easier to edit and fix bugs. And that, I think, ends up translating very much to an efficiency story we haven't talked about, which is the developer efficiency story, right? And serverless, I think, really is resonating with developers, particularly cloud native developers, because it provides them a way to be very productive, very quickly, and be able to do this kind of nimble, small teams that can keep a number of applications running without breaking a sweat, without being on call all the time. Most importantly, I think, though, in this serverless world is there's always been sort of a little bit of tension between the platform and engineering team, the operations team, and the development team, right? The developers build a program, they deploy it into production. At that point, it becomes the production team's responsibility. If a vulnerability happens and it requires rebuilding the software, that team has to kick it back to the development team, and it becomes sort of like one of those tension processes, right? Hey, we need you to fix this today. Well, we're busy today, that kind of thing. If you can, really constrain those binaries to the serverless paradigm where it's a small amount of code, and you've removed a lot of the attack surface in the sense of the, SSL libraries, the socket libraries, all those areas where we always hear about, vulnerabilities or bugs that end up crashing sites. If we can take all of that out of that particular environment, then that tension between the operations team and the development team begins to dissipate. And the operations team is more empowered to be able to do what they need to be able to do, while the developers are more empowered to do the work they need to do without necessarily that interruption-driven process between the two. And I think that's a big part of what's attractive about serverless as a development and operational paradigm.
Yeah, I mean, I really like where you were going with that, because the fact that the developer, it almost levels the playing field too, because you give that, I mean, tell me any developer here that wants to say, I want to work in maintenance mode, right? They want to focus on innovation, right? They want to
please put me on the 2 a.m. shift.
Yeah, of course, right? Why not? But this gives you that kind of a way to advance your development process, be innovative, and really focus on the next generation. But with that said, and as we're kind of wrapping up our last bullet here, is this an all or nothing approach? Do I have to take an all WASM approach, or can I have this kind of a hybrid environment?
Yeah, and that's what's really cool about SpinCube, right? So here's a technology that says, hey, you've already invested in Kubernetes. Your platform engineering team has already, done all the work to batten down the hatches, to build runbooks. Everything is well into production. Nobody's going to want to say, okay, well, let's just put that all on the shelf. Let's start again with WASM. Let's rebuild all the code. So what we wanted to do is with SpinCube was build a way where you could run those WebAssemblies like inside of your existing Kubernetes cluster, side by side, with your container-based applications, often interacting with each other with no problems whatsoever. And the security team is still auditing the same surface, and they still understand how to check that all the service mesh still works. Platform engineering is largely the same. The developer experience should be simplified by Spin and these smaller serverless functions instead of the bigger applications. But it ends up just working together with an existing technology in such a way that platform engineering teams can rest confident that they've got a technology that they can operate successfully on day one.
Nice. That's really impressive because, I mean, that way it allows for rapid acceleration and faster time to value, but also expand to innovation, right?
Yeah.
And focus on those areas where you can move towards that future growth.
Right.
So Matt, as we're wrapping up, what are some parting words you'd like to leave the audience? Where can they go to get started?
The easiest place to go is fermyon.com/platform. You can read about our platform, kind of get a quick link into some of the videos that will show you some of these performance gains, some of the documentation that will show you how it works within Kubernetes, and plenty of material where you can say, is this for real? You know, how are these numbers really achieved? And read through some of our white papers.
Very good, Matt. It's always a pleasure talking to you.
Likewise.
And you know, I respect your insights and your perspective, and I also want to thank the audience for attending our session today. And with that, feel free to contact us at thefuturumgroup.com.